Hello guys, welcome to Surveying Solutions, your number one channel where you get solutions to your surveying problems. So today we are going to consider photogrammetry and remote sensing. So on that topic we are going to look at flight planning. You know, with the recent, or let's say as the drone technology is getting rampant nowadays, most of these calculations are no longer necessary doing them like manually. So the softwares or maybe the applications on your phones can help you determine so many of the things we want to do today. However, for academic purposes and maybe for the beginning, we still need to understand some of these basics, and that is what we are going to share with you today. So we have a particular question, as you can see, an area 24 kilometers long in the northeast direction and 13.7 kilometers wide in the east-west direction is to be photographed with a lens having 304.5 millimeter focal length. And then they say the size of the photograph is 23 by 23 centimeter. So the average scale is to be 1 in 20,000, effective at an average elevation of 213 meters above the sea level. Now the overlaps for the coverage is 60% and 25%, and the ground speed of the aircraft, that is the platform mounting the camera, is to be maintained at 90 kilometers per hour. The flight lines are to be laid out in a northeast direction on an existing map having a scale of 1 in 50,000. So they said we should determine the data for the flight plan. So this is just a simple, let's say, a theoretical flight planning, something that somebody did, or maybe something that can actually be done. So now they say we should do what? We should determine the data for the flight plan. Now the first thing we are going to do is we are going to extract the parameters that we are given to us from the question. So from the question we can see that the length of the project area is 24 kilometers, the width of the project area is 13.7 kilometers, and then the length of the camera is 304.5 millimeters. And then they told us that there was an average scale of 1 in 20,000. The photo format is 23 cm by 23 cm, and then the average height above the sea level is 213 meters. And then the overlaps, the side lap is 25%, while the end lap is 60%. That means the part of the area, like the area that appears on maybe two pictures rather. So the speed of the aircraft, the ground speed of the aircraft rather, we have 90 kilometers per hour. And then they say the map scale, the base map, is on a scale of 1 in 50,000. So we should determine what the data for the flight plan. So there are a set of formula we are going to use, and the formula has actually been spelled out here. The ground distance between principal point, the ground distance between adjacent points, the number of photos per strip, the number of flight lines, the total number of photographs, the time interval between exposure. Then we are also going to look at how we will get the elevation, then the altitude. So without much delay, we will continue with the computation. So as I told us earlier, most of these things we want, if not all of them, there are softwares now that can actually do all these things for us. But for the purpose of building, like for the basics, we still need to understand how these things are done, so that when we see them on those softwares or maybe on those applications, they won't be completely strange to us. So now let's go back to where we would start our computation. So the first thing is that they said we should determine the data for the flight plan. So we are going to first of all compute for the flying elevation. We are going to compute for the flying elevation. So now remember they gave us an average elevation, not the flying elevation. So we are going to compute for the flying elevation. Therefore, to compute for the flying height, we are going to use this formula. The formula was coined out of the formula for photo scale. So our h will now be equal to f all over what? The scale. Therefore, we have something like the focal length of the camera used is 304.5 millimeter. Then divided by the photo scale we are having here is 1 in what? 20,000. Therefore, converting this to meter, we can multiply it by 10 raised to power minus 3 or divide it by 1000. So let's multiply it by 10 raised to power minus 3. So we have times 10 raised to power minus 3 meter divided by what? 1 in 20,000. So to further process this, we have something like 304.5 times 10 raised to power minus 3 times what? Times 20,000. Because this is actually another division under a division. So by the time you want to process it, you will find out that you will have a reciprocal of this. And if you have a reciprocal of this, which will now be what? 20,000 divided by 1. So that's what we have here. So by the time we now press it on our calculator, we have something like 304.5 times 10 raised to power minus 3, then multiplied by what? By 20,000. So we have 6090 meter. 6090 meter. Then our altitude from the set of formula we have here is h plus the flying elevation plus the average elevation given to us. Therefore, the altitude, which is equal to h plus the h average, will now be 6090 plus the h average given to us was what? 213, all in meter. Therefore, the altitude will now be 6090 plus what? 213. So we have 6303 meter as the what? As the altitude of the aircraft. The next thing we want to determine now is we want to compute for what? The ground distance between principal points. And we've been told that the ground distance between principal points is equal to the length of the photo format multiplied by 1 minus what? Multiplied by 1 minus the end lap divided by what? The photo scale we have here. Divided by the photo scale we have here. This will now be equal to, we have something like, so the length of the photo format as given was what? Remember that the dimension of our photo format is 23 centimeter by 23 centimeter. Therefore, the length is still 23 centimeter. So we have something like 23 centimeter times 1 minus our p. The p we have here is what? The end lap, which is 60%. So we have 60 over 100 divided by the scale we have. The scale we have here is what? 1 in 20,000. So we have 1 over what? 20,000. I hope you are actually following the class. So the next thing we are going to do is something like this. We have something like 23 centimeter, then times, remember that these two are together. So when we say 60 over 100, 60 over 100, we have 0.6, which is this. Therefore, 1 minus that answer, we have 0.4. So we have 23 cm multiplied by what? 0.4. Are we together? Divided by 1 over 20,000. And then remember how we computed this particular on this stage, what we did at this particular stage. So we can have something like 23 centimeter times 0.4 times what? 20,000. Are we together, please? All right. So now the next thing we are going to do is that in order for us to convert this to meter, we are going to divide it by 100, or we are going to say 23 times 10 raised to power minus 2 meter times 0.4 times what? 20,000. This 10 raised to power minus 2 simply means we are dividing this 23 by what? By 100. Are we together? It's alright. So the next thing we are going to do now is we are going to press these values on our calculator. So we have 23 times 10 raised to power minus 2. To make the work simpler, let's just get that result first. Then multiplied by times 4.4 rather, times what? Times 20,000. So the ground distance between principal points we have here is what? 1840 meter. And this is approximately equal to 1.840 what? Kilometer. That means you are going to divide this by 1000. So by the time you divide it by 1000, you have its equivalent in what? In kilometer. Are we together? It's alright. Now the next thing we are going to compute for now is the ground distance between adjacent points. The ground distance between what? Adjacent points. And we've been told that the formula for the ground distance between adjacent points is equal to what? The width of the photo format times 1 minus what? The side lap divided by the photo scale. So we have the width of the photo format, which is the width of the photo format times 1 minus what? S all over, we have our photo scale here. Therefore the width of the photo format, since the photo format is 23 cm by 23 cm, our width is still 23 cm. So we have 23 centimeter times 1 minus what's the side lap? We have a side lap of what? Of 25%. So we have 1 minus what? 25%, which is 25 over 100, divided by what? 1 over 20,000. So the same thing we did the other time. We have 23 centimeter times, 25% is 25 over 100. Are we together? It's alright. 25 over 100. So we have something like 0.25. So 1 minus that will give us what? 0.75. So we have 0.75. So the next thing we are going to do is to what? Is to multiply it by 20,000. So we now say multiplied by what? 20,000. Please, if you don't understand this step, it was explained in the first stage there. So we have multiplied by 20,000. So the next thing now we are going to do is we are going to convert this to what? We are going to convert this to meter. And how do we convert it to meter? I told you either you divide it by 100 or you multiply it by what? 10 raised to power minus 2. So we have 23 times 10 raised to power minus 2 meter times 0.75 times what? Times 20,000. Are we together? It's alright. So now the next thing will now be what? 23 times 10 raised to power minus 3 will give us 10 raised to power minus 2 rather, I'm sorry, will give us 0.23. Therefore we have 0.23 times 0.75 times what? Times 20,000. So we have times 0.75 times what? 20,000. So what do we have? We have 3450 meter. That is 3,450 meter. So this is approximately equal to 3.450 kilometer. So this is actually the what? The ground distance between adjacent points. Are we together, please? Please, if you don't really understand any of this step, you can always pause. You just go back, you get it, and then you come forward with us. Now the next thing we want to compute for is what? The number of photo per strip. That means on each of the strips that was covered, the number of photographs, in each of the strips rather, the number of photographs that were covered. So the next thing is what? Number of photos per strip. And the formula for that, as was given, is equal to what? The length of the project area divided by what? The ground distance between principal points plus 4. So this is the formula for that. Now, what's the length of the project area? The length of the project area, as we got from the question, was what? 24 kilometer. 24 what? Kilometer. So we have the length of our project area as what? 24 kilometer divided by the ground distance between principal point, which we computed here, was what? 1840 meter. its equivalent in kilometer is what? 1.840. Therefore, for the units to be the same, we are going to use its equivalent in kilometer, which is 1.840 kilometer plus what? Plus 4. Therefore, this and this can go. We have something like 24 divided by 2 by 1.84. So we have 24 divided by what? 1.84. So we have something like 13.043 plus 4. So if you now say plus 4, we have something like 17.043, which is approximately equal to what? 17 photos per what? Per strip. Are we together? So on each strip that they went, they actually captured 17 photos. So now we want to calculate the number of flight lines. That means the number of times the area camera went through the project area. The number of flight lines. We haven't actually drew the project area and also how the flight lines and everything went. We are going to do that at the end of the video. So we want to calculate what? The number of flight lines, and we've been told that the number of flight lines is equal to the width of the project area divided by what? The ground distance between adjacent point, then plus 2. So what's the width of our project area? The width of our project area, as we got from our question, is what? 13.7 kilometer. So we have 13.7 kilometers, and then what's the ground distance between adjacent points? As we computed the ground distance between adjacent points to be what? To be 3.450. So in kilometers rather, 3.450 kilometers, then plus 2. These two units are the same, so they can just go off like that. Then we come to our calculator. We have 13.7 divided by what? 3.45. So we have something like 3.971 plus 2. So plus 2 will give us 5.971, which is approximately equal to what? 6 flight lines. 6 flight lines or 6 strips, because this was actually the flight lines. Then the next thing we want to get is the number of photographs. That means the total number of photographs that were captured during this particular flight planning, or during this particular, the number of photographs that will be captured, because this is actually planning. So the number of photographs that will be captured. So the total number of photographs as we actually got from the set of formula there is equal to the number of flight lines times what? The number of photos per strip. So we have number of flight lines multiplied by what? Number of photo per strip. Therefore, what's the number of flight line we have? The number of flight lines we have is 6, and the number of photo per strip is what? 17. We have 6 multiplied by what? By 17. So we have something like 6 times what? 17. So we captured, or we are going to capture 102 photographs. 102 photographs. I hope we are really following the process. Because it's actually an interesting process. By the time you finish this thing theoretically, and then you find yourself trying to fly any form of unmanned aerial vehicle or whatever the case is, you should be able to understand that, okay, even on the softwares or maybe the applications on your phone, by the time you now see that, okay, by the time you adjust the number of photographs per strip and you adjust number of flight lines, you see its effect on the number of photographs. You can now appreciate the beauty of this foundation. You can now appreciate the beauty of this foundation. So the next thing we want to determine now is we want to compute for the time interval between exposure. That means the time between, like, the camera is taking the photograph, the time interval between exposure. So that was given as time interval. They gave us as equal to what? The ground distance between principal point in kilometer all over the speed of aircraft, the ground speed rather of aircraft, then times what? Times 3,600 seconds. The ground distance between principal points in kilometer divided by the ground speed of the aircraft multiplied by what? Multiplied by 3,600. So that will give us the time interval between exposure. So what's the ground distance between principal points in kilometer? As we've actually computed earlier, the ground distance between principal point is what? 1.840 in kilometer. So we have 1.840 actually in kilometers divided by then what? The ground speed of the aircraft. The ground speed of the aircraft as given to us was what? 90 kilometers per hour. So we have the ground speed of the aircraft as what? 90 kilometers what? Per hour, then multiplied by 3,600 seconds. So by the time we carry out the computation here, we have 1.840 divided by 90, which is 0.020444 repetitively times 3,600. So times 3,600. So we have 73.6 seconds. That is the time interval between exposure. That is the time interval between what? Between the exposure. So now this actually is the last data for this flight planning we are going to compute. This actually is the last data for this flight planning we are going to compute. And then the next thing we want to do is that let's just see a diagram of how this particular flight planning will look like. Now we've been told the length of the project area and the width. So let's say we have something like this, and we have something like this. So definitely this is our length, the length of 24 kilometers, and then this is our breadth or the width of what? 13.7 kilometers. So from the question we've been told some things. The area, an area this long in the north-south direction and this in the east-west direction is to be photographed, the lens, and by the time we go to this point, the flight lines are to be laid out in a north-south direction on an existing map having a scale of 1 in 50,000. So if we want to consider that, that means it actually went this way. So this is actually how the, what do you call it, the aircraft went along the project area. So so far we've been able to determine the, what do you call it, we've been able to determine the altitude, we've been able to determine the ground distance between principal points, we've been able to determine the ground distance between adjacent points. That helped us to get the number of photos per strip, the number of flight lines, the total number of photographs, and then what? The time interval between exposure in seconds. And we've also gotten that. And we just gave a, let's say, a schematic diagram of how this particular flight will go when they are on site trying to capture the data, because it is going in the north-south direction. So however, this is the much we are going to take on this particular video. And I also want us to note that there are softwares, there are applications, the drone deploy. I think drone deploy is for Android and some other operating systems. So there are some softwares and there are some applications that can do these things for us within a shortest period of time. you just put in your data and then it will give you the information you need for your flight planning. But for the purpose of learning in school, understanding the basics, we still have to do some of these things we did. So thanks for coming to class. I know maybe you have some questions, or maybe you want to make a comment on the video. The comment section is there. Please just talk to us, or maybe you can just reach us via WhatsApp. It's on our description there, or maybe on our on our Facebook page. We'll always get back to you. So once again, thanks for coming to class. And then if you're a returning viewer or maybe a subscriber, thanks for coming. If you're a new subscriber, please, if you're a new viewer rather, you just have to help us subscribe and then hit the like button. So until we see you again, make sure you take your studies seriously, and then make sure you also stay safe in this period of coronavirus. Thank you very much and have a nice time.